we're here to talk about AWS AppSync. So AWS AppSync, you said Amplify, which is okay because Amplify is like the front end of AppSync. So, if you're going to you're going to learn how to build an API, but you're going to need a client one day, right? So it's okay, it works. So we're going to go through first the AppSync basics. We're going to learn what AppSync is, what GraphQL is. If you guys aren't familiar with that, you're going to get a nice little intro for it. So don't worry if you don't know. And then we are going to walk through an AppSync solution, an API. We're not going to build it live because I have 30 minutes. So I'm going to show you code. I'll show you a little bit in the console. And because I am an infrastructure as code person, you're going to see a serverless framework YAML file for how to do it because we don't build things in the console, right? Then we're going to talk about some monitoring and troubleshooting practices, best practices as well. And like everything, AppSync is a tool, and you use tools for the right job. So we're going to talk about some pros and cons to AWS AppSync because it's not always the solution. I know, it's shocking. That an AWS product might not always be the solution. And I'll give you some key takeaways from that. So I'm kind of curious, anybody here familiar with AppSync? A little bit, okay. Anybody familiar with GraphQL? A little bit. All right, a little bit better. So AWS AppSync creates a serverless GraphQL with also pub subs. And it's an API that simplifies our application development that kind of abstracts GraphQL server. So you don't need to worry about the GraphQL server. It's a single endpoint that you can securely query and update and publish data. So I'll show a little bit about GraphQL since people are not familiar with it. But think about the fact that AWS AppSync is going to simplify your backend development. You don't need to worry about your GraphQL server. You don't need to worry about any of that setup because it's already done for you. It abstracts that layer away from you. It enables real-time capabilities and offers like a flexible way to efficiently retrieve data. And it supports multiple platforms. So it provides this integrated security so you can talk to SQL, you can talk to DynamoDB, you can talk to a REST API. And with that, it also ensures the scalability for you. It's working serverless. It's a serverless service, and it does all the scaling for you because it works like Lambda, okay? This is a vital component for modern web application development. It empowers our developers to deliver responsive and interactive and scalable applications to our users if you use it correctly. Oh. This is stolen from Amazon because I'm not going to make my own diagram. So the GraphQL API we're going to just talk about the components within AppSync. So GraphQL API is built with our AWS AppSync. There are some core components. That is the API, which is the central part for our AppSync. It combines all our data and our databases together. And I can't really do a mouse to hover, but the API acts as our entry point for our clients to send GraphQL queries and mutations. Mutations is our creating of data or deleting of data. Finding myself again, and subscriptions. So within GraphQL, we have things called resolvers. Resolvers in AWS AppSync define the mapping between our GraphQL operations, those queries, mutations, subscriptions, and then how it interacts with the data sources. So how you go from this query to then retrieve that data. That's what's being defined. That can be defined using a language called VTL. It can be defined with a JavaScript function. You can even do a Lambda, custom Lambda resolver. So it's a lot of fun. VTL stands for Velocity Template Language. Then we also have GraphQL schema, all right, and introspectives. But schema in AWS AppSync defines the structure and the types of data that's available. This is what you can query. This is the information you can retrieve. This is also what you can create, how you're going to do those mutations, how you're going to In the world of REST, you would say, I want to post or put my data. That's what that schema is defining. And the clients get access to that schema, then they know what they can and cannot do. Finally, data sources. The data sources right now, we got Amazon DynamoDB, we got Aurora, open search services, calling other lambdas that do a job for you. That's where, if you wanted to talk to an Oracle database, I guess that's where you would live. I feel sorry for you if you're in there. And you can do your HTTP endpoints. So what's GraphQL, right? I'm talking about AppSync, and I'm talking about this GraphQL, and you're like, what is this? So GraphQL is a query language for APIs. It gives your clients the power to ask for exactly what they need. GraphQL was created by Facebook, I don't know, a long time ago, maybe 5, 6 years ago. Everything's a long time ago in that time, right? It was created to make their mobile application faster. They had a problem. They're retrieving too much data. They were calling too many requests, and they were just dealing with just retrieving a lot of data that they didn't need. They just wanted comments, the replies to the comments, that's it. So how do you do that? They created this entire way to say, okay, I am going to query exactly what I want. I retrieve back what I want. Why is this useful? Because it saves you on bandwidth. So now you're calling what you need, you're getting what you need. It saves you on the nested data. If you didn't want all those replies to a comment, well, don't do it. You don't ask for it. And it also helps you with retrieving data from multiple sources. Maybe comments and stuff live in one database, and the images for the post live in another database. And so now you make one call to one endpoint. It does all the work to query all that. The client doesn't need to know that. It also solves another problem that's not on here, is overfetching and underfetching of data. So you call get user, and you get all the information about the user, and more data than you need. That's overfetching. Underfetching is I call for a user, but then I also need the organization of that user, and then I need the hierarchy here, so I end up making 5 calls. Well, now I'm going to be, that's underfetching, because now I have to make 5 different calls. So let's go back to REST, right? REST versus GraphQL. Hopefully you're getting a visualization here. In a REST API, we're at public sector, so I'm talking about a library. So the example here is we have a library catalog system. So in this case, if I have a REST API, I'm going to have an endpoint to get books. I'm going to have an endpoint to get a specific book. I'm going to have an endpoint to create a book, update, delete, do the same for offers, yada, 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 a bunch of endpoints. So in GraphQL, you have a single endpoint. So here, this is a single endpoint. It's on the /GraphQL, and the client calls a query or a mutation. So the query at the top is query books. That gets all your books with the attributes that you want. In this case, I want the ID, the title, the offer. If I don't want the ID, I remove the ID. I don't need it. Then it won't return it back. It's there in the data. That's where the bonus is. It's flexible. So if I want to get a specific book, in this case, I just add a parameter. It's ID. You have to obviously set this up, and we'll look at how we set it up later. You have a mutation. So if I wanted to create a book, I have all my inputs that I define. If I wanted to update, there's an update down there. And then finally, delete. So this is one endpoint. The client has the query. You've defined the schema. It's not the client just going into there and querying whatever they want. You have a defined schema of what they're allowed to access and what they're allowed to update and delete. If delete book doesn't exist because you don't want people to delete books, it doesn't exist. They can't do it. It will fail. You can also define more complex queries so that you can actually traverse a relationship. In this case, I have a book, and books are related to an offer, so there should be an offer of the book. So I'm getting the book, and I also want to get the author's name and their bio, find out who they are. And I can make that call. So, high level, right? As best that we can do. That was 10 minutes. We did good. So now, or well, sorry, grammatically correct would be well. So what are we building? So we have Well, in this case, we're not building the client, but we have a client. In our case, our client's going to be Postman. So we have a client. It's going to authenticate. So we have Amazon Cognito in this case. This really nice thing about AWS AppSync is they have a lot of security features that are already tied in. I want to make it do Cognito, it does Cognito, a little setup. If I wanted to make it use an API key, that's easy as well. There's IAM roles, so you can do IAM functionality, and then you can also do your own custom authentication. So you could bring in a POP token or something, and then define your schema that way. Then we have the AWS AppSync, and then we call DynamoDB. It really is that simple, okay? I'm not joking with you, that's what it is. You can get it more complicated if you have a lot more data sources. You could, have 5 million data sources that you're going to, but you still have AWS AppSync. So let's switch to turning on this laptop again. It went to sleep. And for the people that were here early, I had to switch to light mode. And my disclaimer, I don't use light mode. But it works better in this color, in the setup here. So this is the serverless function. I don't really want you guys looking at that right now. What I want you to see is, let's talk about creating an offer. So this is VTL. It's a little bit different. You can do this with JavaScript, but as you will, it will eventually end up in my cons a little bit, is that sometimes you run into a wall, and the way to do it is you'll get the answer on the forums of, have you tried just writing it in VTL? So, but yeah, I'm like, okay, I'll just write in VTL, I guess. So this is VTL. In this case, I am defining a JSON object that then would do the operation to put an item in our DynamoDB table. So this is basically just an action that calls DynamoDB and goes, here you go, put it in, and this is the request. So this is the pre-work. It gets that JSON element, calls DynamoDB. This is orchestrated by AppSync. AppSync does that call. And then it will return back a response. In this case, I'm just returning back a result. I got the result because DynamoDB, when you put an item, it gives you back the item that it puts. I take that, turn it into a JSON object. That gets translated into the schema. So that's called a unit. So that is a unit resolver. So this resolver focuses, it does one thing. So if I go into, this is my schema. This is in my sandbox here. So this is the schema that actually has been defined. I have a type that's an author, and then I have a book. These exclamation points, as you guys might be familiar with, means it's required. So I have defined mutations. These are mutations to create a book, to update a book, delete, and then we create offer and delete offer. And our delete doesn't really delete, it just puts a deleted date on it because, we hoard data, right? It's good, just like I hoard craft supplies. And then we have our queries. So we have our query to get a book by a specific ID. We have a way to just get all the books. And then we get an offer by a specific ID or get all the offers. When you define your schema a little bit more, you'll end up using like input parameters. So you would actually set up inputs. This, again, is a simple example. We don't need to overcomplicate things. It's just important to see where we start. So if I'm looking at that mutation, oh, I got to refresh. Please be logged in. Otherwise, we will just ignore that and go look to the serverless YAML instead. Mutation. You don't want to show me anything? Okay. We're not logged into the console, so we'll just be, it's on cache mode. It's like, yeah. So that's okay. So what I've called that is a unit. So I'll go down to here instead and go into our serverless. And A unit does one thing, makes sense. The other type of resolver is a pipeline. And a pipeline does several functions. So my offer, when I create an offer, I'm only modifying that one record, and when I update that offer, I'm only modifying that one record. When I create a book, I'm creating the relationships as well, because I was a crazy lady and I made a single table design for my DynamoDB because I like a challenge. So now I'm creating all those relationships with the book. I'm adding a book object, I'm adding the book's offer relationship, I'm making sure it's all there, and all those actions I have to say, okay, I need to get the offer because I'm passing in an ID of the author ID, but I don't have the offer's info, but I need the offer's info. So we get the offer, then we create the book, we create the book offer, create the author book. That is called a pipeline. So within the pipeline, we define functions. So in this case, I have a get offer, a create book. All these pipelines map to a certain data source. The data source, you define it. In this case, it's called library. Library is defined as a DynamoDB with the table name. And I have different stages, so I have my dev, test, production. So that is our library catalog. And this is a DynamoDB that has been defined with the CloudFormation template because it's easier that way than using serverless framework for that. So when you make a pipeline, go up to this create book. When you make a pipeline, you define the type as a pipeline. You don't actually need to do this. This is the default. So normally, if you create it in the console, which is what I wanted to show, but it's not logged in, so we just move on. We create our book. It would default it as a pipeline because most of the time, you're doing something that's a little more complicated. You don't really want a unit. When you have a pipeline, you have a before mapping template, which will be where you store things within your cache. So you would take an object and you add items to your stash. So in this case, I would have, and this is how I organize. I have functions and mutations, and then here's our pipelines, because that's the sanity that you have. So beforehand, you want to add items. This is where I'm going to say, okay, I'm going to make an ID because I'm creating a book. I'm going to generate this ID here. So then I use that ID in every other function that I call. I have, now I could have stashed this at a whole JSON object, but this was easier. It's better to show everybody, right? So we could put our title, our publish date. These are things that are going to be used globally. Basically, you're setting your little global parameters because Lambda and all that is stateless. We have to handle that. So then we have our functions that get set up, and they will do the actions that we have. Looking at my time. So I'm going to move really quickly over. This will all be on GitHub, by the way. So you guys want to look at it, it will be on my GitHub. So I'm going to go here, just show working example, because I am connected to the internet. So we're going to get a book. So this was it with Stephen King. And if I wanted more info, I want his bio. Some dude that writes a lot. So it really is just getting what you want. I want the ID. I get the ID. There's the book's ID. That you ask for what you want, you get what you want. Within the constraints of what the schema says you can do. So it was really easy on the surface, but nothing's really that easy, right? So you are going to run into issues, and that means that you need to be monitoring. Make sure that you're using CloudWatch. AWS AppSync has a verbose option where you can check it, and then it's going to log your request headers and the responses and everything. Do that. You will be very happy when you've done that, because if you don't do that and then the first thing something catches on fire in prod, you're like, why do I not know what's going on? So do that. Enable X-ray to trace and analyze your requests so that you can gain insights into how you can actually improve your request lifestyle. You got to think about continuously improving. In order to continuously improve, got to monitor to know what you need to improve. Otherwise, you just got people going, it feels slow. I'm like, it feels slow, okay? Make sure you're logging, make sure you're handling errors. I didn't show within the code there. There are parts where I am popping up and showing the GraphQL errors that occur from the DynamoDB. Do that, right? We just don't say it just works, all right? And then make sure you have tests, write unit tests, write integration tests. Catch it beforehand, because especially with GraphQL, you have a schema. If someone makes a change to a schema, that's a breaking change. You don't want to find that out when suddenly all the contracts and everything aren't working in production. So again, common errors, common issues, right? Schema issues. I lock down my schema. So every company that I've ever worked at, not just Kaplan, when I've worked with GraphQL, that schema is locked down, right? People, you better have a good reason you're modifying that schema. And we also have to make sure that we handle when we make something out of date, right? So for some reason, the word has left my mind, but hopefully you guys know what I'm getting at, because usually in REST, you have different versions. We don't really need to do versions, we decommission. So we slowly work on a decommission within a GraphQL schema. So versioning is a little bit different, so keep that in mind so that you lock down your schema, handle that, and make sure you do your communications properly. Resolver misconfigurations, and you guys could see from that serverless YAML, you don't set up your resolver correctly, you're gonna have a bad time, all right? So make sure that you double check you're hitting the right database, you're querying the right way, test authorization, access controls. You can make sure that you test your authorization. We had in the last talk, someone was asking about them getting a 502 on a certain Lambda function. I was just like, that is definitely, like that definitely over in your endpoint policy or your IAM rules. So you got to make sure that you're aware of what you're doing, because otherwise, again, you're going to have a bad time. I'm going to just say you're going to have a bad time. There are performance bottlenecks. That's where monitoring is important. You have to be monitoring so you know when you're having your performance problems. I've got like 7 minutes, so I'm going to just go a little bit faster. AWS AppSync has caching already. You can just enable caching. It's very nice. If you work with GraphQL if you work with GraphQL, and implementing caching is a challenge. So it's nice that you're able to just click the box and turn on caching, but you have to make sure you configure it correctly. You don't want to have stale data. You don't want to be, so basically you don't want to cache too aggressively or not aggressive enough. It's a balance. It goes back to monitoring. So I'm a broken record. It's okay. Finally, cost optimization. Yes, AWS AppSync is in the free tier. So a lot of time you're going to be fine. You're going to be happy. It's just like Lambda. Until you start processing tons of data, you have a heavy write, or your downstream database starts getting really expensive, you know. So, and that's like the dangers within Lambda itself, right? It's cheap until it's not cheap. So keep that in mind. Again, monitoring. It's really cool. I sound like a nerd. So going back to best practices. So I talked about locking down your schema, is also keeping your schema modular and maintainable. AWS just released 2 weeks ago, I'm allowed to talk about it now, Merge API. So Merge API is now with AppSync, where you can have multiple AppSyncs and then they'll merge together to do the final call. So the client still goes through one, they combine the schema together. But that's how you can actually even modularize your schema even more. So when you start getting really complicated use cases, when your application grows beyond that MVP, start thinking about how you can break out that schema. Implement security. We have private API now, actually, as well. That was a month ago. Which goes to keeping, actually I'm going to skip, is like keeping up to date with AppSync because of the fact of all these improvements that are constantly happening within AppSync. But implementing authentication, having your authorization mechanisms, don't just leave your things open in the public. Implement your data caching strategies. do error handling, do logging, and consider your client when you're implementing. So I'm a full stack engineer, so this is why I'm this way. Is I don't just go, I'm building an API, I'll meet the front end later. Think about what the front end is doing. Think about what they need to query, what information they need to retrieve. What is the standard way that they're going to be doing something so that you can optimize your queries. So think about the client first, not the back end first. Think about it in a full picture. And I will say, don't skimp on testing, like test from the beginning. Continuous improvement, I hit it when I was talking about the fact paying attention to AppSync updates. Pay attention to what it is doing. It is a live service. It's not dead. It is, they have many, many users breathing down their necks, asking for lots of things. So maybe I'll get a building named after me one day with all the stuff I tell them to do. So keep doing that. Pay attention to their information. Also provide them feedback as well, things that you have problems with, to ask for more improvement. That's the only way we're going to improve these services. Remember, they're customer obsessed. We're the customer. All right, and document. Document, collaborate. Don't expect people to know. GraphQL is very different from REST. If you come in thinking that you know what you're doing, you're going to be really sad when you realize that everything's a post. Everything comes back as a 200, even when it blows up. So it goes back to pros and cons. So pros and cons of AppSync, okay? So pros, we have a simplified backend. We're abstracted away from the GraphQL server. We don't really need to worry about it. Real-time updates and subscriptions exist. It's able to be handled really well. AppSync does this beautifully. It's scalable. You know, you don't have to think about it. You don't have to worry about how many Kubernetes clusters you need to be running and all that. It does it for you. You just problem solved. Not my EC2 instance, right? It's working. It's flexible and customizable to an extent. Put a little asterisk there. I should have put an asterisk next to it. But it is flexible and customizable. And you have your built-in security and access controls. You can even go down to the fact that you can deny specific fields on your schema. So if you have PII information and one client can access an SSN, but another client can't, you can have that. So now if client B, who can't access SSNs, wants to access it, they won't get it back. It'll be null, even if it's there. So you have those field denies in there. Cons, it's a learning curve. GraphQL is a learning curve. VTL is a learning curve. The thinking in an abstracted service is a learning curve. So asking people to come in and jump into an abstracted service, even if you think about the first time you went into Lambda, right? You had to learn. So that's what you're going to be dealing with. I know it's an AWS conference, but vendor lock-in. You implemented something with AWS AppSync, and now you want to move to Azure. Good luck. All right? Yeah, no, that's all I got to say. Good luck. Cost considerations. It scales, right? Automatically. It scales automatically. So keep that in mind. Goes back to monitoring, paying attention. Don't assume it's just working. You have a limited built-in data sources, right? You saw it there. You could do Aurora. You could do DynamoDB and HTTP endpoints. After that, you're going to have to write a Lambda function to do those custom integrations to get to other sources. And finally, VTL is really complex, and even though we always try to avoid it because you're going to start off and go, okay, I'm going to do JavaScript, and it's going to be fine, and then you find out in the forum, they're like, just do it with VTL, and then you go, why do I have to do it with VTL? But once you learn it, you're good. So going back, I hope you guys really enjoy this. I'm just reiterating for a second here, is make sure that you understand the core components of AWS AppSync because it's crucial. Make sure you understand GraphQL. Don't take it don't take it at face value. Consider security and do regular testing. Thank you, everybody, for coming today, and please fill out the survey.